Lesson 11.5 is going to walk us through solving rational equations. This video is going to be a little bit long so that you can see lots of examples of different types of problems. So, keep on practicing along with the video and you'll catch on. First off, a rational equation is an equation that contains two or more rational expressions, meaning we contain two or more fractions, okay? And we're going to see how it's pretty easy to solve these by using the least common denominator. So we're going to make that a lot, okay? This is just one way to solve. There are other techniques, but I'm going to teach you the least common denominator method. So the first thing we're going to do is we're going to look at each of our denominators. And in this case, we have a 3, we have an x, and we have another x. And we're going to break them apart into their factorization. So, okay, 3 is the only factor of 3, and x is the only factor for x. So we know that the least common denominator has to have a 3, and it has to have an x. So what we are going to actually do is take our whole equation, and I like to write it kind of spaced out so I have room next to it, and we're going to take each term times 3x over 1. We're going to multiply the whole equation by the least common denominator. Okay, and the really cool thing that multiplying by the least common denominator does for us is it's going to eliminate your denominators. So the first thing we have to do is we have found the LCD. Then we're going to multiply by our LCD. Then we're going to do the canceling step, and this is the cool part. Okay, because if I take a 3x and I multiply it on top, well, guess what? A 3 divided by a 3 cancels out. Here, x on the denominator cancels with this x in the numerator. And x in the denominator here cancels with this x in the numerator here. So, I get x times 1 over 1 times 1. So I have x plus 3 times 3 is 9, and it's all over 1, so I don't have to show dividing by 9. 1. And then 2 times 3 makes 6, and it's all over 1, so I don't have to show dividing by 1. So I get the equation x plus 9 equals 6. That's my new equation. Now I can solve it. Subtract 9 from both sides, and x equals negative 3. It's always good to check your answers by plugging back in. So let's check. 1/3 plus 3 over negative 3. Does that equal 2 over negative 3? So 1/3 minus 1, does that equal negative 2/3? Yes, because 1/3 take away 1 is negative 2/3. So x equaling negative 3 is a good solution. Let's try the next problem. First thing I have to do is figure out my LCD. So the factors of 7x are 7 and x. The factors of 3 is 3. And the factorization of 3x is 3 times x. Remember anything that you have in all your denominators? Okay, you only have to use one time. So we need 1x, because we have a pair. We need 1, 3, and then we need to have that 7. So our least common denominator to have factors, use out all the factors. We need a 7, we need an x, and we need a 3. Okay, so that'll make 21x, or you could write it as 3 times 7 times x. So now I'm going to copy my problem and space it apart. So 4 over 7x plus 1 over 3 equals 7 over 3x. And I do this because I like to have space to multiply by my LCD right next to each term, because then it's easy to see what I'm doing. Okay. Essentially, when you write it down next to each term, it's like saying I put the whole equation in parentheses and I multiplied the whole equation by 3 times 7 times x, and I distributed it to each term, and I just showed that right away in the first step. Now we can do that cool canceling. So, 7 on top cancels with the 7 on the bottom, and the x on top cancels the x on the bottom. Okay, here 3 on the bottom, 3 on the top. Here 3 on the bottom, 3 on top, x on the bottom, x on top. If you found your least common denominator correctly, you should always end up with everything on the denominator canceling out, and you just have 1s down there. So now we have 4 times 3 left from here, all over 1, plus 1 times 7 times x, so 7 times x, equals, and on the top we have 7 times 7. So 12 plus 7x equals 49. Subtract 12 from both sides, 7x equals 37. And divide by 7 on both sides. That's going to be ugly. X equals 37 over 7. And again, we could check our answer by plugging it back in to the original equation. So, some of our problems are going to require us to use factoring. And you're going to see here that we have more groups to work with. Alright. So again, I'm going to look at each denominator. I have a y and I have a y squared. And I'm going to write down what their factorization is, so I can figure out what the least common denominator should be. Okay, you can see here that we have a pair of y's, and then we have an extra y. So the least common denominator is going to be y times y, or y squared. So I'm going to take my problem and rewrite it, leaving lots of space. And then I'm going to multiply each term by my LCD over 1. And I like to write it in its factored form, because then it's easier to see the canceling happen. Okay, so use my highlighter here. A y from top cancels a y from the bottom. And see, we have one left on top. Here I have 2 y's for y squared, so I have to cancel out both y's on the top. And then here we just have the 1's, so there's no canceling to do in our last term. So now let's write. We have 5 times y equals 6, because there's nothing to multiply on top, minus 6y squared. This problem is a quadratic, because we have a y term, a constant term, and a squared term. So we have to make this whole equation equal to 0 in order to solve. So we'll have 6y squared, we have a positive 5y, and we have a negative 6 when I move them all to the left side. Okay, oops, that means I need to do some factoring to solve. So 6 times negative 6 makes negative 36. Factors of 36 that add up to 5 would be 9 and 4. So I'm going to use 6y squared plus 9y minus 4y minus 6 as my factoring. Now I can take out a 3y from each of the first 2 terms. And I can take out a negative 2 from each of the next terms, because a negative divided by a negative turns positive. And I get one factor group 2y plus 3, and a other group 3y minus 2. Now I can solve each of these factors. So 2y plus 3 equals 0, 2i equals negative 3, and y equals negative 3 halves. And then my other one, 3y minus 2 equals 0, so 3y equals 2, and y equals 2/3. Those are the 2 solutions to our problem. You can always go back to the beginning and plug them in to check your work. Alright, now in this case you can see that d plus 6 doesn't have a denominator, so remember addition keeps things as a group. So each of these terms here is a group, so d plus 6, d plus 11, d plus 3. So the parentheses can help us. And then we want to compare our denominators. We have a denominator of 1, and we have a denominator of d plus 3, but d plus 3 can't be factored. So our LCD is d plus 3, because d plus 3 times 1 is still d plus 3. So I'm going to rewrite my problem, and I'm going to leave just some spaces in it. And I'm going to remember to write each of my groups in parentheses when I write it down. Okay, addition groups always go in parentheses. That way it's easier to think of how to factor and multiply them. So now I'm going to multiply by my LCD over 1. So d plus 3 over 1. And here I'm going to multiply by d plus 3 over 1. Now, you should see that again we can cancel. Here I don't have anything to divide by on the bottom, I just have ones. Over here I have a d plus 3 group on top and a d plus 3 group on the bottom. And since that makes a ratio of 1, I can cancel it out. Now, you should see that we're left with d plus 6 times d plus 3 on the left equaling d plus 11 on the right. Hopefully you recognize this as cross-multiplying. That would also work because we have two ratios equal to each other. Now we're going to have to FOIL. First terms, d squared. Outside terms, 3d. Inside terms, 6d. Last terms, plus 18, equals d plus 11. Since we have a squared term in it, we know this is a quadratic, and we need to make it equal to 0 to solve. So I'm going to subtract 11 from both sides. That gives me d squared, let's see, 3 plus 6 is 9. Take away 1 makes 8. And 18 take away 11 makes plus 7 equaling 0. Now I'm going to try to factor this, because I like factoring. Since it starts with 1d squared, I can look for easy factors of 7 that add up to 8. That'll be 1 and 7. So d plus 1 times d plus 7 equals 0. And then I solve. D plus 1 equals 0, and d plus 7 equals 0. That gives me the two solutions, d equals negative 1, and d equals negative 7. So you can see that oftentimes you're going to end up with more than one solution in these problems. Oh! Okay, here we go. Sorry about that. You can see that often we have more than one solution. Okay, as you go. Last problem on this page. How can you tell by looking at the equation 2 divided by x squared equals negative 1 that there are no solutions? Think about that for a minute. Hopefully you notice that any number squared will always be positive. Okay, if I take a negative 2 and I plug it in, I always get positive 4. Well, if I always get a positive number for this squared term, I can never have it equal negative 1. So, there's just a little interesting math problem for you. Alright, here's a couple word problems for us to try. Alright, here we go. One host can fill a pool in 12 hours. Another host can fill the same pool in 8 hours. How long will it take for both hoses to fill the pool together? Alright, so there are a couple different ways we can approach this, and I'm going to show you two different ways you can set up your equation. One way is to say if hose A can take 12 hours, that means in 1 hour it does 1/12 of the pool, and then hose B, it takes 8 hours, which means it does 1/8 of the pool every hour. And we can say, well, we'll compare that to the time it'll take to do the whole pool. So we can say 1/12 plus 1/8 has to equal 1/t. Okay, because we want to do the whole pool, like how much time. Okay. The other way we can think of this is to say that the ratio of time for 12 hours, filling it like 12 hours per pool, plus time per 8 hours per pool, equaling 1, because we want to do the whole pool. Okay, and this gives us a different way to understand the ratio. You notice we have the same kind of setup going on though, ratios equal to a total. Now, for either way you solve this, you still want to use the LCD. So let's solve it using the setup on the left. I like this setup because it's kind of like comparing pool sizes, like filling one pool and then hours. So one pool takes 12 hours plus one pool taking 8 hours, equaling one pool for how many hours it'll take them. And this shows that they're doing it together. That's why I like adding the fractions this way. For this method, I'm going to say, okay, 12 is made up of 3 times 4. And 8 is made up of 2 times